Hi everyone, here's a super quick help video on what I would like you to do with the data we collected when we squished those sponges in a previous class. So I worked with a couple of students and this is the data that we generated. I'm not entirely convinced this is going to work properly, but it may. This is a big experiment in trying to make this hands-on. So anyway, I put 3.9 pounds on a 22 square inch surface area of a sponge, and 3.9, so the stress is F over A, force divided by area. 3.9 divided by 22 was 0.18. The original height of the sponge was 1.75. That's the same for all of us. But when I put this 3.9 pounds on the sponge, it got a quarter inch shorter. It went from 1.75 inches tall, it went down to 1.5 inches tall. So the change in length, or the change in height, in this case was 0.25 inches. And the strain was the change in length divided by the original length. In this case, the change in the height divided by the original height. So 0.14 is a quarter inch divided by 0.175. And that right there, 0.14, well, that's the fraction that it shrank, right? It's 14% shorter. It got 14% shorter when I put 3.9 pounds on it. It got 20% shorter when I put 4.4 pounds on it. It got about 29% shorter than it originally was with 6.1 pounds on it. And it was about 50% shorter, about half its original height, when we had 8.3 pounds on it. So what I'd like to do is go to these tabs here and graph this data. Right? So the first graph is weight versus displacement, load over displacement. So that's rise over run, right? So this is the y-axis, rise, over run, that's the x-axis. So this is important. Let's go get delta L, okay? Let's go get delta L first because we want that on the x-axis, rise over run. X-axis is first, so let's just go like this. Copy this data. You can do Command C or Edit Copy. Right, Command C. I just copied it. We all know how to copy. Let's go here and make two new columns. Let's get these yellow. I'm going to choose them both and go to the paint bucket here and make them yellow. And so this is delta L, so displacement. So this is displacement. This is how far it got squished. And those are the numbers I just copied, so I'm just going to go ahead and put them right there. I just pasted, edit, paste. I just did Command V. Okay, so displacement, and this is load. This will be the y-axis, load. So let's write that in there. L-O-A-D, L-O-A-D, load. All right. So the reason I'm doing it in this order is because this program, when I tell it to make a graph, it's gonna read these numbers first and make those the x-axis, and it's gonna read these numbers second and make these the y-axis. So since it says here weight over displacement, that's rise over run. Rise is weight, so that'll be y-axis over here. Okay, so let's go get the load data. It's right here, the weight, 3.9, 4.4, 6.1, and 8.3. Command C to copy it. Back to this tab to paste it here. Command V to paste it. And now I'm ready to make a graph. Okay, so I'm going to choose just the data. Make sure there are no units in here, like inches or pounds or anything like that. Just numbers. And secondly, put them in numerical order. Right, so least squished to most squished. Quarter inch up to, what's that, 3/8 of an inch, I believe. No, that's more like 7/8 of an inch, probably. Sorry, quarter inch all the way up to nearly an inch. Okay, so in numerical order here. And this should follow, right? The one that squished it the most should be the heaviest weight, and the one that squished it the least should be the least weight. Right, so once you've chosen those data and put them in numerical order, you choose them and you go to Insert, Chart. And it may take a second, but there it is. Let's go to Scatter. So not quite a straight line. I might go to area chart. I like the looks of that. Ideally, this would be nearly a straight line because, because a given amount of weight should squish it, and twice the weight should squish it twice as much, and 3 times the weight should squish it 3 times as much. This should be a linear graph, but any slight misread is going to result in the graph being a little wonky. But you can see. Let's see if we just continued this line here without that, we'd be up over here. It's pretty close to linear, but it's got a little bit of. I look forward to seeing yours because any one trial like this one, any one trial could have a mistake for sure, and so I look forward to seeing yours for sure. Make sure you move this off of your data. Don't have it over your data. I want to see the data, and I want to see the graph next to it. Let's go to the next one. This one's stress over strain, rise over run, y-axis over x-axis. So let's go here and do stress. So rise over run, y over x. So strain is x-axis. Let's put it here. Right? And stress is y-axis. So let's put it here. And let's make these. Let's highlight these 2 blocks. Make them beautiful. Any color, I don't care what color, but just highlight them some color so they stand out a little bit. Now let's go back to our data we collected, and it doesn't matter. We want stress and strain. So I'm going to just, strain is right here. I'm going to copy it, go back to the tab. This is strain. This is strain, so I'm going to put it here. I'm going to go get the stress data. The stress data is right here. I'm going to copy that, and I'm going to put it here. Same thing. Then I'm going to choose just the numbers. Make sure they're in order. 0.14, 0.2, 0.29, 0.5. These are in numerical order, and and make sure there's no units, no inches or psis or anything, and no units, and in numerical order. And then again, just insert chart. Let's do that area chart again. I like the looks of that one. We don't really need to know the area under the graph, but that's okay. It just makes it easy to see what's going on here. It's a really similar graph because these are derived from the previous data. So is it linear? Because it should be. Well, nearly so, but any one data point can throw us off of linearity. So if we continue this one, it'd be almost a straight line. There's a little bit of a bump here due to perhaps just one bad trial. So again, make sure I can see your data and this window. And once you complete these 2 charts, now you're ready to go ahead and submit this activity. So go ahead and smash that submit button, and I'll see you in the tension activity.